Okay, 6.4, we learned about what a logarithm was. And a logarithm is always a power. One more time, the logarithm of a number to a base is equal to a power. And that means that your number is your base raised to your power. So this is called the logarithm form of a number, and this is called the exponent form of a number. And keep in mind that we keep hollering that it's a power. And let's watch these laws of logarithms. Here's the first one. The logarithm of two numbers multiplied together is the log of the first plus the log of the second. Now that's easy to understand. Let's review a little bit of algebra. X squared times x cubed. When you multiply like bases, it says that you're supposed to add the exponents. So this is going to give me x to the 5th power. Well, a logarithm is a power. So when you're multiplying, you're going to add the logarithm. That's your first property of logs. The second property of logs is the logarithm of two numbers divided is a log of the numerator minus the log of the denominator. Again, go back. If you got x to the 5th divided by x to the 3rd, when you divide like bases, you subtract the exponents. So this comes out to be x squared. So the logarithm of a quotient is the log of the numerator minus the log of the denominator. Now, your third law, the logarithm of a number raised to a power is the power times the log. I want you to look carefully at that one because we use it real often. Go back to your algebra again. What happens when you raise a power to a power? Well, you multiply them, and that's going to give me x to the 12th power. And that's what we're saying here. This is the power times the log, but the logarithm is a power. So it's the power times the power. One that we use real often is this. The logarithm of a number to a base is the log of the number divided by the log of the base. This one is real powerful. The logarithm of a number to any base is the log of that number divided by the logarithm of the base. One that they use, in fact, you use this for homework, is an expression like it's a base raised to the power, the logarithm of a number to a base. And that comes out to be the number. Working your problems. Okay, a cute little problem. I don't want to use the log, I want to use the ln. The logarithm of e to the 10th power. Okay, so that's going to be 10 times the ln of e. But this is cute. Ln of e is going to be 1 because the logarithm of a number to its base is always 1. Let's try it with our old friend 10. The logarithm of 10 to the base 10 is 1 because if you put it in exponent form, 10 is equal to the base, which is 10 to the 1st power. Very, very important that we memorize the logarithm of a number to its base is always going to be so if I put numbers on it, the logarithm of 4 to the 58th power using base 4. Well, This is my power, so that's going to be 58 times the log of 4 to the base 4. But the log of 4 to the base 4 is 1, so that's going to be 58 times 1. So that power property we use. Now, this is a problem out of your homework. 5 times the log of x to the base 2 plus 3 times the log of y to the base 2. Okay, you're not going to get a final answer to this thing. He wants you to combine this mess. So let's go backwards. This is out front, so that means that it's a power. So that's a logarithm of x to the 5th power to the base 2. So this means I got the logarithm of y to the 3rd power to the base 2. Now this only works because I got the same base. But look, these two logarithms are added. So I can write down the logarithm of x to the 5th, y to the 3rd to the base 2. So all we've done is took our original problem, which was expanded, and we wrote it in a more compact form. As I said, we don't have a numerical answer. It's given to us in terms. Got another one here, the logarithm of square root of x to the base 6 minus the logarithm of x cubed to the base 6. Well, we had to make a between step. Square root of x means I got x to the 1/2 power minus the logarithm of x cubed and base 6. Now, and I keep emphasizing you have to have the same base. But here we're given base 6. Now, these two logarithms were subtracted, so that means that my two numbers are divided. So that's a logarithm. Let me pause for just a moment. No, I couldn't. Okay, sorry for that interruption. So this, when you divide like bases, you subtract the exponents. So I have 1/2 minus 3. So this is going to give me logarithm of x to the minus 2 and 1/2 to the base 6. Okay, let's look at the logarithm of 42 to the base 7. So according to the formula, that's the log of 42 divided by the log of 7. Now in this case, you would simply look up on your calculator the log of 42 and divide it by the log of 7. Okay, I made the statement in section 6.4 about the inverse. Let's go back to that section that we did the other day. And let's draw the graph of y is 2 to the x. When x is 0, y is 1 because 2 to the 0 power is 1. And when x is 1, y is 2. So that graph looks like this. Now, let's draw the graph of the logarithm of x to the base 2. Now, let's make us a chart. When I let x be 1, the logarithm of 1 to any base is always 0. Now, when I let x be 2, the logarithm of 2 to the base 2 is 1. And if I have 4, the logarithm of 4 to the base 2 is 2. Now, if I let x be a half, the logarithm of a half to the base 2 is going to be minus 1. Now, let's plot these. You have 1, 0. You have 2, 1. You have 4, 2. And you have 1/2 minus 1. Now, you draw this graph. Now, look at those two graphs. On this graph, I had 0, 1. On the log graph, I got 1, 0. On the exponent graph, I had 1, 2. On the logarithm graph, I have 2, 1. So all that's happening is that the x's and y's are swapping. Well, that's the way we said we found the inverse the other day. You swap the x and y's. And if you look at those two graphs, you can see that the graph with the dotted line, y is equal to x, is the line that would be their line of symmetry. I think this is enough for you to be able to do all of section 6.5. I realize that when you do it on the computer, he's going to have 4 or 5 parts to each one of these problems, but that's the basic information. Good luck.